Right now we're talking special case factoring, and what's special about this thing is that it's not a quadratic. Remember, quadratic started with the variable being squared, then to the first, then just a constant. Well, this is a different sort of pattern. I have to the fourth squared and then nothing.
Can't you just add a 0?
Well, won't work the same way. What I can do,
Multiply by 1.
let me just ask you this. If I had had this problem, p squared plus 4p plus 4, like we had last week, and I asked you to factor that thing. A is 1, right? So you would just take factors of c that add to be b. So what would my answer have been here? What are factors of 4 that add up to be 4? 2 and 2. So this thing would have been p plus 2 times p plus 2. Right? Well, the only difference now is it's not this, it's this. It's p to the fourth and a p squared there. So do you remember when we played that Jeopardy game, the one thing that we changed in this to make it reflect this? There was one little teeny tiny thing we had to do. Think about it. When I multiply the two first terms together, I'm supposed to get p to the fourth. Right now, p times p is just p squared. Yeah, so I make these both p squareds.
You can't just do that.
I can.
You can't.
I just did it.
That changes the problem.
No, what I did, I changed the problem by writing this. That's not what the problem was. The real problem is this. So, let me put those in green so you don't think that they're different. Watch, when I FOIL this back together, watch what happens. First, p squared times p squared is p to the fourth. Outside plus 2p squared. Inside plus 2p squared. Last plus 4. P to the fourth plus 4p squared plus 4. There it is. So, one of the special cases that you come across with trinomials is this quadratic pattern. So, this number, this exponent being twice as big as this one, and then this one not having an exponent at all. So, let's try another one that's like this. How about number 45? N to the fourth plus 2n squared plus 1. If it's a trinomial, guys, I'm telling you right now, they all basically factor the same way. There's only 3 terms. A is 1, so I still just want factors of 1 that add to be 2. What are factors of 1 that add to be 2? 1 and 1. So instead of it just being n plus 1 and n plus 1, it's going to be n squared plus 1 times n squared plus 1. Because remember, I have to get to n to the fourth. So anytime you see this pattern, it's the same idea. I just factor it like normal, but then I make my first term squared.
So anytime you see like 4,
Absolutely. Okay, let's try, I'm going to make one up. How about x to the fourth minus 9x squared minus 10. Okay, Al, you have an answer? Go ahead.
X squared minus 10x squared plus 1. Wait, did we do 45 yet?
Yeah.
Is it just n squared plus 1?
Yeah, both, two of them. So
Oh,
answer.
okay. So where are we at now?
I made this one up.
Oh, that's right.
Is this a final answer? N squared minus 10, n squared plus 1. Yeah, you can't go any further than that. You're done. Try this one for me. You have an answer? Hold on to it. Gianna, you have an answer too?
Yep.
Hold on to it. Okay. Everybody tell me, what are factors of negative 9 that have to be negative 8? Negative 9 and 1. Instead of writing x, I write
X squared.
x squared. So a negative 9 and a, what'd you say, positive 1? Are you done? No. You're not done this time.
Oh, it's a perfect square.
Yes, that's the difference of two perfect squares. It just so happened that you have a perfect square and a perfect square, which means you're not done. You have to split that one again. Ooh, tricky, tricky. Whoa, why would they be squared? Yeah, it's just x. So this guy's going to split into x plus 3, x minus 3. What about this one?
It stays the same.
It stays. You can't split that up because that's a plus. So it just stays x squared plus 1. That is a final answer. Ooh, tricky, tricky. Yep, sure. When you go to put your answer on the answer line, you have to be checking. Can any one of these parts be factored any further? Is there a common factor that I missed taking out? Let me take it out now. Is there the difference of two perfect squares that I didn't notice? Let me do it now. Okay, what do you think?
I have a question on number 9.
9. Sure. How about we do it? So number 9 says 7a to the third plus 3a squared minus 7a minus 3. This thing has 4 terms. So this is where I'm going to split it into two groups. But first, I will see, is there a common factor to take out of the whole thing? No. Excuse me. Too bad, so sad. So right after the second term, draw your line. What can you take out of the left? A squared. I can take out a squared and I would be left with 7a plus 3. Everybody agree? You can always distribute that back in to double check yourself to make sure that you get right back there. What do you do on the right hand side? You're going to take out a negative 1. If I take out a negative 1, won't I be left with 7a plus 3, which is exactly my goal? I want those parentheses to match. By the way, they don't match if you have like one of them's like x plus 3 and the other one's x minus 3. That doesn't match. So there's an issue if you have something like that. But these, they match exactly. They have to be exact replicas of each other. They are. So now that means, what are my a squared minus 1 and 7a plus 3. Am I done?
You're done.
That's the difference of two perfect squares. You have to split it again. Because the square root of 1 is 1. 1 is yours, well, 0 is a perfect square too. But 1's a perfect square. And then so is 4, 9, 16, and so on. But you can't forget about 1. 1 times 1 is 1. So that splits into a plus 1, a minus 1. And then I just bring down the 7a plus 3. So always be constantly looking for.
Sylvia, why would we do that? Aren't we trying to simplify it?
You're trying to factor this. You're trying to break it down, just like you would take the number 50 and do a factor tree. You're trying to break it down into its prime factors.
So anytime you get n squared, you have to split it? Or a squared?
If this number is also a perfect square, then yes. If it had been a squared minus 3, well, 3 is not a perfect square, so I can't do anything.
Oh.
But if I have, so if you rewind back up here, for example, I got x squared minus 10 and I didn't do anything about it. Because 10 is not a perfect square. But 9 is, so in this one, I had to split it. So always be looking for those difference of perfect squares. Always be looking for, in your parentheses, I shouldn't have any common factors. So if you had an answer like this, for example, 7n squared plus 7, you're like, oh, hold on a minute, I could take a 7 out of that. So as you're writing your final answers, you need to be checking for those things, because you don't want to keep losing points for something that could have been fixed. Okay.